So, I want you to try a little experiment the next time you leave your house.
Okay.
Just walk down the street. And it really doesn't matter if it's, a bustling downtown canyon or just a regular suburban strip.
Right.
But I want you to really look at the buildings.
Which is, it's harder than you think.
Oh, for sure. Because I don't mean look at the window displays or the coffee shop signs. I mean, look at the structures themselves.
Yeah, we're completely conditioned to ignore them.
Exactly. We treat them like background scenery in a video game.
Yeah, they're just sort of there,
Mm-hmm.
solid, static.
Right. But here is what we are digging into today. That solidity is an illusion.
It's a total illusion.
When you actually peel back the skin of a city, you don't just find bricks and mortar. You find this chaotic, high-stakes collision of physics, economics, and law.
And that really is the trifecta. You
Yeah.
absolutely cannot have a building without all three of those things.
Exactly. I mean, we see a wall, but a developer sees a load-bearing element.
Right.
We see a height limit, and a city planner sees a zoning envelope.
Yep.
Or we look up and see a weirdly shaped roof, but an engineer is seeing a snow load calculation.
It's honestly like learning to read the Matrix.
It really is.
Once you understand the vocabulary of commercial construction, you can never walk down the street the same way again.
No, you really can't.
You start seeing the invisible skeleton
Mm-hmm.
and the rule book that forces that skeleton to be shaped the way it is.
So that is our mission today for this deep dive. We are decoding the language of the built environment.
I love that.
And we're basing all of this on a really comprehensive technical guide to commercial construction.
Right.
Now, the source specifically uses Ontario standards as a baseline, but honestly,
Gravity and economics work the exactly same way in New York, London, or Toronto.
yeah, physics is pretty universal.
Very universal. And the desire to make money on real estate is also pretty universal too.
Definitely. So by the end of this hour, I want you, the listener, to be able to look at a warehouse or an office tower or honestly, even a barn
Yeah, even barns.
and understand its class, its bones, and really why it exists in that specific spot.
And to understand the risks too.
Yes, the risks.
Because if you're looking to lease space or buy a building, or frankly even just work in one, there are major red flags hidden in plain sight, if you know where to look.
I have to admit, before reading through this source material, I was definitely one of those people who just nodded along when someone mentioned, HVAC or zoning setbacks. I knew they were important words, but I didn't know why. I sort of just assumed a building stands up because it's heavy.
The old "it's heavy so it stands up" theory,
Exactly.
which is actually a very old school way of thinking, and we will get to that. But we really need to frame this entire discussion around those three pillars I mentioned earlier.
Safety, economics, and law.
Exactly. Let's break that down. Safety is the engineering. Basically, will this kill someone if the wind blows too hard?
Right.
Economics is the driver. Does this shape maximize the rent per square foot?
The money side.
Right. And then law is the constraint. Does the municipality actually allow you to build this thing here?
Someone's a tug of war.
Always. Usually, a finished building is just a compromise between those three forces fighting each other.
I really love that framework. So let's start with the first pillar, the physical reality, the bones of the building.
The structural materials.
Yeah, because when we look at the history of how we build, it feels like our buildings have gone on a diet.
That's a very accurate observation.
We went from these massive, thick stone walls to these incredibly spindly glass towers.
We really have moved from mass to efficiency.
Right.
If we go back to the classic method, basically the grandfather of commercial construction, we are talking about masonry,
So bricks.
specifically load-bearing masonry.
Okay, so this is that classic Main Street look, right? The
Yeah.
red brick, maybe 3 stories high.
Exactly. Now, in a modern building, the wall you see is often just a curtain. It's just hanging off a hidden frame,
Like wallpaper almost.
basically.
Yeah.
But in a load-bearing masonry building, the wall is the frame.
Oh, okay.
The brick isn't just there to keep the rain out, it is physically holding the roof up.
Which really explains the windows.
How so?
Well, I've noticed older buildings rarely have those massive floor-to-ceiling glass walls.
Right, they literally can't.
Because of the weight.
Yeah.
Yeah.
If you punch a giant hole in a wall that is carrying the entire weight of the building above it, the building falls down.
Makes sense.
So instead, you get those very rhythmic punched windows, usually with arches or thick headers above them, to transfer the weight around the hole.
Now, despite being really old tech, the source material was actually pretty complimentary about masonry.
Oh, it's fantastic for certain things.
It mentions something called thermal mass.
Yes, thermal mass is a huge benefit. especially in climates with really big temperature swings.
Like we have here.
Right. Brick and concrete are very dense, so they act kind of like a thermal battery.
A battery.
Yeah, they absorb heat from the sun all day long, and that keeps the interior of the building nice and cool. Then at night, when the outside temperature drops, they slowly release all that stored heat back into the building.
Oh, so it naturally flattens the curve of the temperature changes?
Precisely. It's naturally energy efficient without plugging anything in. Plus, it's incredible for soundproofing. And fire resistance. I mean, a brick wall doesn't burn easily.
And there is always a but in real estate.
There's always a but.
There was a term in the source that honestly sounded like a floral arrangement.
I know exactly what you're going to say.
Efflorescence. It sounds pretty, yet apparently it is a total nightmare for building owners.
Ah, yes, efflorescence. It sounds beautiful, doesn't it? Like, look at the lovely efflorescence on that facade.
I am assuming it is not lovely.
No, it's a pathology.
Yeah.
It's a disease for a building. Have you ever walked past a red brick wall, maybe an old school or a retaining wall, and it looks like someone threw a bag of white flour against it?
Yes, or like these chalky white streaks running down the face of the brick. I always assumed that was just salt spray from the roads in the winter. Or maybe just the brick fading from the sun over time.
That is the most common misconception. And if it's right at the sidewalk level, sure, maybe it is a bit of road salt.
Right.
But if you see it 10 feet up in the air, that is efflorescence. And the call is coming from inside the house.
Wait, so the brick is sweating salt?
That is exactly what is happening. Bricks and mortar are highly porous. They are essentially hard sponges.
Okay.
And they naturally contain salts within the clay and the cement. When water gets into the brick, maybe from a leaky roof or a rising damp from the ground,
it soaks in.
It soaks in, and it dissolves those natural salts. Then when the sun comes out and warms the wall, the water migrates to the surface to evaporate.
And it leaves the salt behind?
The water leaves, the salt stays, as that white crystal powder.
Okay, so it's ugly, but is it actually dangerous?
Well, the white powder itself is just salt. It won't hurt you. But it is a glaring symptom of a much bigger problem.
Which is the water.
Water infiltration. If you have efflorescence, you have water moving actively through your wall. And in a climate like Canada or the northern U.S., water freezes.
And ice expands.
Right. It expands with incredible force. When that water freezes inside the brick, it exerts massive hydraulic pressure. It causes what we call spalling. Spalling. This is when the actual face of the brick literally pops off.
Oh, wow.
Yeah, you'll see bricks that look like they've had a bite taken out of them. That is severe structural damage.
Okay.
So if you were buying a building and you see that white powder, don't just think, oh, it needs a quick power wash. Think, I need to find the leak before this entire wall crumbles to dust.
That is a remarkably great tip for anyone looking at real estate.
It saves millions.
Okay, so moving from heavy brick to something quite a bit lighter, wood framing.
The residential go-to.
Right. The source says this is mostly residential, but we are seeing it in commercial applications too now.
We are, but there is a hard ceiling. Literally. Generally, wood framing is very cost-effective, but you typically only see it for much smaller commercial buildings, usually capped at about 6 stories.
Why the limit, though? Is it just that wood isn't strong enough to go any higher than that? Because I feel like I've seen some pretty massive trees out there.
Well, wood is surprisingly strong, especially modern engineered timber products. The limit isn't really about the structural strength. It's primarily about fire safety.
Yeah.
And the building code.
Ah, the fear of the towering inferno.
Exactly. In a high-rise building, you need time to evacuate hundreds of people down the stairs.
Right.
And wood is combustible. If the structure itself is fuel for the fire, that's a huge problem.
Obviously.
Now, the building codes are slowly changing, and we are seeing some new mass timber projects going a bit higher. But for your standard stick building, the code requires incredibly rigorous fire separations.
What does that actually look like in practice?
It usually means layers and layers of drywall, gypsum board.
Just normal drywall?
Yeah, because gypsum actually contains water molecules trapped in its chemical structure.
Really?
Yeah. So when it gets hot in a fire, it releases that water as steam, which actively cools the wall and slows down the fire.
That's amazing.
So if you build a wood-framed office building, you are basically wrapping the entire wooden skeleton in a heavy, fire-resistant, steam-releasing blanket.
Which I guess brings us perfectly to the material that really let us scrape the sky. Steel.
The modern standard. Structural steel.
It's everywhere.
It's what allows for all the incredible design creativity we see today. The sweeping curves, the massive open glass lobbies, the 50-story towers. Steel is incredibly strong for its weight, and it goes up very fast.
And here's where the source got really interesting to me. It points out a massive vulnerability in steel that I had never really thought about.
It surprises a lot of people.
Because we think of steel as invincible. Superman is the man of steel, right?
Right.
But apparently, fire is its absolute kryptonite.
It really is. And this is a very critical concept in construction physics. We all think of wood burning and steel just standing there unharmed.
Yeah, like a frying pan on a stove.
Exactly.
Yeah.
But steel has a fatal structural flaw. It loses its load-bearing strength incredibly fast when it's heated up.
But it doesn't have to actually melt, right?
No, nowhere near its melting point. At around maybe 1,000 degrees Fahrenheit.
Which is what, in a fire?
A standard room fire with couches and paper can easily reach 1,000 degrees very quickly.
Okay.
At that temperature, steel loses about half of its strength. It becomes highly ductile. It essentially acts like wet spaghetti.
That is a terrifying image for someone working on the 40th floor, the beams turning to noodles.
And if the beams start to sag, the floor drops and the building collapses.
Wow.
This is exactly why you almost never see naked, exposed structural steel in a finished commercial building, unless it's very specific, highly treated architectural steel.
So what do they do to it?
Well, if you walk into a warehouse or an office tower while it's under construction, look up at the bare beams. They are almost always sprayed with this lumpy, bumpy, gray, oatmeal-looking stuff.
Oh, I have seen that. It looks like weird spray foam insulation.
It's not for warmth. That is cementitious fireproofing.
Cementitious.
Yes. It's a thick layer of insulation, specifically designed to keep the steel core cool for 2, 3, or maybe 4 hours. Just long enough for the fire department to arrive and actually put the fire out before the steel turns to spaghetti.
So the absolute strongest material we have actually needs the most protection.
It's the great irony of modern structural engineering.
Now, the source also mentioned a trend happening with steel called prefabricated modular steel, which honestly sounded like grown-up Legos to me.
It essentially is giant Legos.
Yeah.
And it's entirely driven by economics.
How so?
Think about a traditional construction site. It is totally chaotic. It's highly weather dependent, and things constantly get stolen.
Like spools of copper wire just walking off the site in the middle of the night.
Exactly. It's a huge loss center. But with modular steel construction, you build the sections in a highly secure, climate-controlled factory. You build the walls, the frames, sometimes you even put in the electrical wiring, and the interior finishes right there in the warehouse.
Wow.
Then you wrap it up, put it on a flatbed truck, drive it to the site, and just crane it into place.
So you could effectively be building the interior walls in a factory while it's a blizzard at the actual job site.
Yes, you completely remove the weather variable from the schedule.
Right.
And you drastically reduce theft. It is incredibly efficient. But it requires absolutely perfect forward planning. You cannot make casual adjustments on the fly like you can with a pile of 2x4s.
Right.
If the steel module arrives on the truck and it's 2 inches too wide for the foundation, you have a massive $1 million problem on your hands.
Precision is definitely key there.
Absolutely.
Speaking of efficiency, let's talk about concrete, but not just, pouring a sidewalk.
Concrete can be very dynamic.
Right, because the source describes something called tilt-up construction, and I actually looked this up on video, and it genuinely looks like magic.
Oh, it is a serious sight to behold on a job site.
Yeah.
This is pretty much the gold standard now for big box stores and massive warehouses.
Okay.
Imagine you need to build a gigantic new Walmart or one of those 1 million square foot Amazon fulfillment centers.
Right, massive scale.
Building those exterior walls brick by brick would take forever. And building traditional vertical wooden forms to pour concrete high in the air is dangerous and requires a ridiculous amount of scaffolding.
So what is the cheat code?
You use the floor.
The floor.
Yeah, you pour the massive concrete floor slab of the building first, just a giant flat parking lot, basically.
Okay.
Then you build the forms for the walls lying down flat on top of that floor. You pour the wall panels horizontally.
So you're basically making giant concrete pancakes right on the floor.
Exactly.
Sure.
Giant 30-ton pancakes.
Yeah.
You let them cure and get hard. Then a massive mobile crane comes in, hooks onto the top edge of the panel, and literally tilts it up into a standing vertical position.
Wow.
They swing it to the edge, brace it, bolt it down, and boom.
Right.
You have a 30-foot high, solid concrete wall finished in a matter of minutes.
That totally explains why so many of those suburban warehouses look exactly the same from the highway.
Yeah, it's the absolute most economical way to enclose a massive volume of space. It's not particularly pretty, but it is totally unbeatable for cost and speed.
Now, on the other end of the concrete spectrum, the source mentioned something I'll call the styrofoam sandwich.
Ah, yes.
The technical term used was ICF.
Insulated concrete forms.
Yes.
This is a really brilliant hybrid technology.
How does it work?
Imagine giant hollow Lego bricks,
Mm-hmm.
but they are made of polystyrene, basically dense white styrofoam.
Okay, I'm picturing a giant cooler.
Right. You stack these foam blocks up to make the shape of your walls, but unlike normal concrete forms made of wood or steel that you peel off and throw away later,
You leave the foam there.
we leave the foam permanently in place.
Right.
You pour the wet concrete down inside the hollow core of the foam blocks.
So the finished wall is a layer of foam, a core of solid concrete, and another layer of foam.
Correct. And because that foam insulation is totally continuous, meaning there are no wooden studs breaking the thermal barrier every 16 inches.
Oh, right, studs leak heat.
They do. But here, there are no gaps. So it has incredible thermal value. It really is essentially a giant Yeti cooler. It keeps the heat in during winter and out during summer incredibly well.
That's smart.
It's becoming very popular for commercial properties where the owner actually pays the utility bills because the energy savings over a 20-year period are just massive.
Okay, so those are the bones of the building. Masonry, wood, steel, and concrete.
The skeleton?
Right, but a skeleton is completely useless without a nervous system and lungs to keep it alive.
Very true.
So let's move to part 2, the essential building components. And we really have to start with the acronym that everyone uses but very few people really unpack, HVAC.
Heating, ventilation, and air conditioning.
The source actually calls it the lungs of the building. And this isn't just about not sweating in your cubicle in the middle of July, right?
No, not at all. And this is where a lot of older buildings get into trouble. In a modern, tightly sealed commercial building, you can't just walk over and open a window to get some fresh air.
True, most of those glass tower windows don't open at all.
They're permanently sealed.
Yeah.
So the HVAC system is 100% responsible for bringing in fresh air from the outside, running it through filters, tempering the heat or cold, and then physically pushing out the stale CO2 heavy air from the people breathing inside.
And if the HVAC is poorly designed or just poorly maintained,
the CO2 levels in the office steadily rise throughout the day.
And then everyone gets super sleepy in that 3 p.m. afternoon meeting.
It's not just the heavy turkey sandwich from lunch. It's the building actively suffocating you.
Wow.
Yeah. High CO2 levels demonstrably lower cognitive function and decision-making skills. So for a smart employer, an excellent HVAC system isn't just a comfort expense. It is literally a productivity tool.
That is a fascinating way to look at it. Investing in air to get better work out of your team.
Exactly.
Now, staying inside the building, we have to talk about weight, because the source draws a really strict distinction between floor loads and roof loads.
Yes.
And specifically, it talks about dead load versus live load. Now, this sounded like a zombie movie to me initially, but I assume it's pure engineering.
It is engineering, yes.
Yeah?
But understanding the distinction is absolutely vital for anyone buying or just leasing a commercial space.
Okay, lay it out for us.
The dead load is the weight of the structure itself. The heavy steel beams, the concrete roof deck, the massive HVAC units bolted to the ceiling. It's the weight that is completely static and permanent. Gravity just always pulling constantly on it.
Okay, so what is the live load?
There's the transient weight, the stuff that moves, people walking around, heavy office furniture, piles of snow building up on the roof in winter, or forklifts driving around a warehouse floor.
Why does a standard commercial tenant actually need to know the difference?
Let's use a real-world example. Let's say you run a commercial printing business.
Right.
You have these massive, incredibly heavy industrial offset printing presses. And you decide to rent a nice, bright space on the second floor of a generic suburban office building.
Sounds nice.
Well, a standard office floor is typically designed by the engineers for a live load of maybe 50 to 100 pounds per square foot. Basically, it's designed to hold people, desks, and some filing cabinets.
Right.
But your industrial printing press might weigh 300 pounds per square foot.
Oh, that seems like a serious problem.
It is a catastrophic problem. You could quite literally punch that heavy machine straight through the floor and crush whatever is in the office below you.
Wow.
So understanding the live load capacity isn't just fun trivia. It strictly dictates what types of businesses can safely operate in that specific space.
Note to self, always check the floor load before buying heavy machinery.
Always.
Now, let's look up. We need to talk about ceilings. The source makes a really specific distinction between clear height and head space. And honestly, these sounded completely synonymous to me.
They are not synonymous at all, and confusing them can cost you a lot of money in a lease negotiation.
Break it down.
Clear height is basically the holy grail for warehouse and logistics operators. It is the usable vertical space measured from the concrete floor straight up to the lowest hanging physical obstruction.
Like a beam.
Usually the bottom of the steel roof girders, or sometimes the hanging sprinkler pipe.
Why does that specific measurement matter so much?
Because of pallets. If you are in the business of storing goods, you stack them vertically.
Right.
A warehouse with a 20-foot clear height might only allow you to stack your pallets 3 high. But a modern warehouse with a 30-foot clear height lets you stack them 5 high.
Oh, I see.
That is literally 66% more revenue generation from the exact same square footage of floor space.
Got it. So in a warehouse, the air is literal money.
The air is money. Now, headspace is something entirely different. Headspace is the gap between those acoustic suspended ceiling tiles,
Yeah.
The drop ceiling you see in almost every corporate office,
Right.
and the actual structural concrete roof deck above it. It's that dark, hidden space where the spies always crawl around in the air ducts in action movies.
The plenum space.
Exactly, the plenum. That space is completely reserved for the building's guts, the ductwork, the heavy electrical wiring, plumbing lines, and the fire protection pipes.
Okay.
If you're trying to renovate an older office building and you really want to put in a modern central air system, but you measure and only have 6 inches of headspace above the ceiling tiles,
You're stuck.
you are in big trouble.
Yeah.
You physically cannot fit the new air ducts into that gap.
Speaking of those hitter pipes, the section on fire protection in the source was surprisingly dramatic.
It's life and death stuff.
I mean, we all know generally what a sprinkler is. It sprays water on a fire. But apparently there is an entire sprinkler hierarchy.
There is, and choosing the right one depends entirely on what you were trying to protect, and honestly what you're most afraid of.
Okay.
The most common type, the baseline, is the wet pipe system. The pipes running through the ceiling are always completely full of pressurized water. A fire starts, it gets hot, it melts a tiny little glass bulb in the sprinkler head, and water sprays out immediately.
Simple, reliable.
Very. But what if the building is an unheated storage warehouse in northern Ontario in the middle of February? Or an open-air parking garage?
Oh, that water sitting in the pipes is going to freeze solid and burst the metal pipes.
Exactly. You'd have a massive, catastrophic flood without ever having a fire.
It's a bad scenario.
Very bad. That's exactly where you use a dry pipe system. In this setup, the pipes running through the cold areas are filled with highly pressurized air, not water.
So the water is held back somewhere else by the air pressure?
Yes. The water is held back in a heated mechanical room by a heavy valve. When the heat from a fire melts the plug on the sprinkler head, the pressurized air escapes first. The pressure drops, the main valve back in the warm room finally opens, and then the water rushes through the pipes and out the head. It essentially buys you freeze protection.
Okay, that makes sense. But what if I'm running something hypersensitive, like a server farm for a tech company? Or a museum archive with rare books?
Right.
I definitely don't want water spraying everywhere just because an employee burned some popcorn in the break room and accidentally triggered a smoke sensor.
Because water destroys computer servers just as fast and thoroughly as fire does.
Exactly.
In that specific case, you need a pre-action system. I like to think of it as two-factor authentication for fire sprinklers.
How does that two-step process work?
Step 1.
Yeah.
A standard smoke detector has to go off. That sends an electronic signal to simply fill the dry pipes with water. But it doesn't spray a single drop yet. It just primes the gun, so to speak. Step 2. The physical heat of an actual fire has to rise and melt the little glass bulb on the specific sprinkler head. Only when both of those things happen does the water spray. It heavily guards against accidental water damage from a knocked sprinkler head.
That is brilliant. And finally, the source described one more system that sounded really intense, the deluge system.
Deluge. This is the absolute nuclear option.
Wow.
Deluge is reserved strictly for high-hazard areas. Think chemical storage facilities, munitions factories, or massive aircraft hangars.
Places where a fire spreads instantly.
Exactly. In a deluge system, all the sprinkler heads are completely open all the time. There's no little glass plug to melt. When the master fire alarm system triggers, it doesn't just spray water on one hotspot. It pumps massive volumes of water out of every single head in the entire facility simultaneously. It's designed to literally drown the entire area in seconds.
That is incredible. So it really is an intricate balance of risk management. Are you more afraid of the fire spreading, the pipes freezing, or the water ruining your inventory?
You hit the nail on the head. That's exactly it.
Okay, so we've built our physical building, we've put in the lungs, we've figured out the loads, and we've run the sprinklers. But we haven't talked about where this building actually sits in the world.
The location.
Which brings us to part 3, the invisible box, zoning.
Zoning is where the municipal law completely overrides structural engineering.
Yeah.
I mean, you might have hired the absolute best architect in the entire world, but if the local zoning code says no, the answer is just no.
The conceptual image that really stuck with me from the source is this idea of the building envelope.
It's the best way to visualize it. Think of it as an invisible 3D geometric shape hovering over your piece of land.
Okay.
The city municipality basically says, hey, you can build whatever you want as long as the entire physical structure fits entirely inside this invisible box.
And what actually defines the shape and size of that box?
A few key mathematical constraints. First, you have setbacks. You almost never can build your wall right up to the very edge of your property line. You need to be set back a certain number of feet from the front road, from your side neighbors, and from the rear alleyway.
Why do they force you to do that?
A mix of reasons. Privacy, fire separation, so a fire doesn't jump easily from roof to roof, and often to leave room for the city to widen the road 10 years from now.
Then there is FAR, floor area ratio.
Yes.
This one felt a little bit like SAT math when I was reading it, but it seems to be the single most important number in all of real estate development.
It is the absolute density cap.
Yeah.
Let's do the simple math together to explain it. Suppose you own a square piece of land that is exactly 10,000 square feet.
Okay, 10,000 square feet.
And the city zoning code allows a FAR of 1.0 on that lot.
Okay. So I can build a building that is 10,000 square feet?
Total area, yes. So you could build a flat one-story building that completely covers the entire 10,000 square foot lot.
Or I could build a two-story building that only covers half of the lot.
Exactly. 5,000 square feet on the main floor and 5,000 on the second floor. That still equals 10,000 total square feet. Or you could build a four-story building on just a quarter of the lot.
But I definitely could not build a two-story building that covers the whole lot.
No, because that would equal 20,000 square feet of total space. That would require a FAR of 2.0. If you submit blueprints trying to do that in a 1.0 zone, the city planning office will reject your permit immediately.
It's just an instant no.
Instant. And this is exactly why property developers spend millions of dollars fighting for what we call upzoning.
Changing the math.
Yes. If a developer can convince the city council to change that zoning number from a 1.0 to, say, a 5.0, they have literally just quintupled the amount of rentable space they can build on the exact same pile of dirt.
That is exactly where the big money is made.
It's the whole game.
Now, one specific zoning rule I found really interesting was daylighting and sightlines. It's highly specific to corner lots.
This one is a pure public safety issue. Imagine you were driving your car. You pull up to a stop sign at a T intersection, and you were trying to turn right.
Okay.
If the property owner on the corner has built a solid brick wall right up to the corner curb, you absolutely cannot see the cars flying down the road from your left.
You're completely flying blind into the intersection.
Right. So zoning codes require a sight triangle. It's a triangular chunk of the corner of the property that must permanently remain clear of tall buildings, high fences, or even thick bushes.
Just so drivers have clear visibility.
Exactly. It effectively forces you to cut the corner off your own building design.
Now, we really can't talk about zoning without talking about the local politics.
Never.
The outline explicitly mentions NIMBY factors, not in my backyard, and something called site plan control. This honestly sounds like the city micromanaging every single detail.
It is absolute micromanagement. It is the municipality's ultimate quality control lever. You might have the exact right zoning, say you have commercial zoning allowing a restaurant, but you still must go through site plan approval.
And this is where they get into the weeds.
Extremely deep into the weeds.
Like what kind of details?
They will ask, where exactly is your garbage dumpster pad located? Oh, it's next to the residential property fence line. The neighbors will definitely complain about the smell in the summer. You have to move it.
Wow.
Or they will demand extensive shadow studies. Where exactly will the shadow of your new 4-story building fall at 4 p.m. in the middle of December? Will it block the afternoon sun for the public park across the street?
They actually check shadows.
They absolutely check shadows.
Yeah.
If you block the sun from a popular public park, The city might force you to chop 3 entire stories off your building design before they approve it.
And then there are the external authorities, like a conservation authority, for instance.
Yeah, the city isn't the only boss. If your plot of land happens to have a creek running anywhere through it, or if it is near a designated wetland, the local conservation authority has total jurisdiction.
What do they look for?
They map out the floodplain. Basically, if a massive 100-year storm hits the region, where does all the floodwater naturally go?
Right.
If your land is situated in that mapped splash zone, you cannot build a structure there, period. It does not matter what the city zoning says. The Conservation Authority will veto it.
It really seems like there are a lot of different people who have the power to just say no to a project.
Dozens of them. The Ministry of Transportation has a say if you are building near a provincial highway. The local heritage board gets involved if your building is over a certain age. It is a massive gauntlet you have to run.
Which honestly segues perfectly to the absolute scariest part of buying commercial land. The unknown horrors lurking beneath the soil. Part 4. Environmental and due diligence. The source lays out a strict 3-phase system, and reading this felt very detective noir to me.
It definitely starts out that way, because it's entirely about massive financial liability. In environmental law, if you own the land today, you own the pollution, even if you didn't cause it.
Wait, really? So if I buy a totally clean-looking empty field today and it turns out someone illegally dumped motor oil there in 1970, that is my problem?
It is 100% your problem. And it could be your problem to the tune of potentially millions of dollars in cleanup costs.
That is terrifying.
That is exactly why you hire engineers to do a Phase 1 environmental assessment before you close the deal.
Okay, so Phase 1.
Phase 1 is the paper trail. You don't actually touch the dirt yet. An environmental expert goes to the archives and looks at historical aerial photos from 1950, 1970, 1990. They check old municipal fire insurance maps.
What exactly are they looking for in these old photos?
They're looking for ghosts. An old gas station that was torn down, a dry cleaner, a chemical auto repair shop, basically anything that historically used harsh chemicals. If the historical records show that a gas station stood on your pristine field back in 1965, the engineer flags it as a potential area of environmental concern.
So then what? You go to Phase 2.
Yes. Phase 2 is the drill. Now you actually have to verify if the ghost left a mess. They bring in a heavy drilling rig, punch deep holes in the soil grid, take physical samples of the dirt and the groundwater, and send them off to a lab.
And if the lab results come back showing high levels of old hydrocarbons or, arsenic,
then you officially have a dirty site. Now you have 2 distinct choices. You can walk away from the real estate deal entirely, which many people do.
Right.
Or you move to Phase 3, remediation. You legally have to clean it up. And usually this means digging up thousands of tons of contaminated dirt and trucking it away to a highly specialized toxic landfill. It is incredibly expensive.
One really specific risk the source highlighted here was underground tanks.
The silent killer of commercial real estate deals.
Yeah.
Yes. Decades ago, almost every building was heated with heavy heating oil. And that oil was stored in a large steel tank buried in the backyard.
And as we know, steel rusts.
Steel eventually rusts. The tank slowly leaks. The heavy oil seeps into the surrounding soil and the groundwater table. If you buy a property with an old leaking tank, you are fully responsible for digging it up and cleaning all the soil it ever contaminated.
Wow.
And worse, if that oil slowly migrated across the property line onto your neighbor's property, you are paying to clean their land too.
That is an absolute financial nightmare.
It really is.
Now, there is also a human health risk mentioned here called sick building syndrome. We briefly touched on this earlier with the HVAC discussion. But is this an actual recognized medical diagnosis?
It is a recognized issue,
Yeah.
and more importantly for landlords, it's a massive legal liability issue. Sick building syndrome is when the occupants of a building experience acute health effects, things like chronic headaches, severe dizziness, lingering respiratory issues that are directly linked to the amount of time they spend inside the building.
So they feel better when they go home.
Exactly. It's usually caused by hidden mold in the HVAC ductwork, or sometimes from off-gassing.
Off-gas.
Yeah, cheap synthetic carpets, paints, and glues slowly releasing VOC chemicals into the sealed air. If your building makes people physically sick, you will quickly lose all your tenants, and you will very likely get sued.
Okay, let's pivot from the terrifying unseen threats to the actual specific types of buildings we interact with every day.
Let's do it.
Because the source material does a really deep dive into 3 main categories of commercial space: Office, retail, and industrial.
The big three.
Let's start with the office building. I honestly didn't realize there was a highly formalized class system for them. It reads like school grades.
It does, and it really helps the real estate market easily communicate value and prestige. At the very top of the pyramid, you have Class A plus scheme.
Okay, so what makes it an A plus co?
These are the trophy buildings.
Like the ones they put on the city postcards.
Exactly. The absolute tallest glass towers, the prime downtown financial district locations, soaring marble lobbies, usually designed by international architects. The HVAC is completely state-of-the-art. The elevators are the fastest in the industry. This is where the major global banks and the top-tier corporate law firms live.
Okay, so then what is just a regular Class A?
Still an excellent building.
Yeah.
Very good location, high-quality modern finishes, professional institutional management. It's just maybe not the absolute defining icon of the city skyline.
Got it. And Class B?
Class B is highly functional. This is the grand average.
Yeah.
The interior finishes are just, okay, maybe you have commercial carpet instead of imported stone in the lobby.
Right.
The mechanical systems are a bit older. The location is good, but maybe it's a block or two off the premium Main Street. It's built for the mid-sized company that needs a really solid office, but doesn't feel the need to impress international billionaire clients in the lobby.
Makes total sense. And finally, Class C.
The bottom tier of the grading system. Usually these are much older buildings, 20, 30, or 40 years old. They usually desperately need a renovation. The windows might be a bit drafty in the winter. The core internet infrastructure might be a bit slow. But the rent is incredibly cheap. This is exactly where scrappy young startups usually begin, or where companies put their back-office call center operations.
Now, once you are inside these office buildings, the physical layout really matters. The source talks extensively about the core of the building.
The core is the absolute spine of the tower. It contains the elevators, the public bathrooms, the emergency stairwells, and the main utility shafts. You generally see two distinct architectural designs for this.
Okay, what's the first one?
Center core. The elevators and bathrooms are clustered right in the dead middle of the building, and the usable office space wraps entirely around them in a big donut shape.
What is the main advantage of the donut?
Windows and light. Everyone is relatively close to the exterior glass. If you have a massive floor leased out to 4 different small companies, center core is fantastic because every single company gets a slice of the outside view.
And what is the alternative design?
Side core. You push all of the elevators, stairs, and bathrooms tight to one solid windowless wall on the far side of the building.
Oh.
This creates one massive, completely uninterrupted floor plate.
Like a giant indoor football field.
Exactly. This design is vastly better for a single, massive corporate tenant, like a Wall Street trading floor, or a huge tech company with endless rows of open-plan desks. They want to be able to see everyone across the entire room without a giant concrete elevator bank blocking the view in the middle.
Fascinating. Now, one term that initially confused me in the source was curtain wall, because it honestly just sounds like living room drapes.
It does, but it's actually the glass skin of a modern skyscraper. In a new high-rise, the exterior outer walls don't actually hold up the weight of the building. The thick internal concrete columns do that. So the glass facade just hangs there, like a curtain bolted to the edge of the concrete floor slabs. It is totally non-structural. It just keeps the wind and weather out and lets the sunlight in. But you could theoretically unbolt and take all the glass off, and the core building would still stand perfectly fine.
Wow. And before we completely leave office buildings, we really have to talk about how you actually pay for them.
The math.
The Beaumanet standard. Honestly, reading this felt like learning a magic trick where the landlord just makes rentable space appear out of thin air.
Oh yes, the dreaded gross-up factor. It's the eternal battle of rentable area versus usable area.
Please explain this to me like I am a naive tenant about to sign a 10-year lease.
Okay. Usable area is the actual physical space safely inside your specific office walls. It is the carpet you can actually walk on. The physical space where you put your employee's desk.
Right, and that is exactly what I want to pay for.
Of course you do. But the landlord says, wait a minute. You and your employees use the fancy lobby downstairs to get in. You use the public hallways. You use the shared bathrooms.
Okay, yes we do.
That is all classified as common area. So the landlord takes the total square footage of all that shared common stuff, does some math, and divides it proportionally among all the tenants in the building.
And they just silently add it to my rent invoice?
Yes, they do. That final inflated number is the rentable area. So if the building has a massive, echoing, 2-story marble atrium, that serve absolutely no purpose other than looking grand for visitors. You are physically paying rent for a tiny slice of that empty atrium air every single month.
So a super fancy Class A building with a huge, impressive lobby actually has a much higher gross-up factor. I am literally paying for more empty air.
You are paying a premium for the prestige of that air. Yes.
Painful, but really good to know. Let's shift gears and move to part 6, retail.
The psychology of shopping.
Exactly. We all know what a mall is, obviously. But the source breaks them down into a strict hierarchy based on size and draw.
Right. It scales by size and what we call gravitational pull. At the very top, you have the super regional mall.
The behemoths.
Massive, fully enclosed, easily 800,000 plus square feet of retail. Think of the Mall of America or the West Edmonton Mall. It has multiple huge anchor tenants, usually massive department stores, that actively draw shoppers from hours away.
Right. Then you step down a tier to community and neighborhood centers.
These are much smaller. They're usually anchored by a large grocery store or a chain pharmacy. You don't drive an hour on the highway to get there. You go there because you desperately need milk and it's close by. The draw is pure convenience, not a grand experience.
But the really interesting shift discussed in the source is the rise of the specialized retail forms, like the Power Center.
Yes, the Power Center. This is essentially a massive collection of big box stores. You definitely know the look. It's a vast sea of asphalt parking surrounded by a Best Buy, a giant Home Depot, maybe a Staples.
Right.
We call these stores category killers.
Why do they intentionally group together like that?
Because it is strictly destination shopping. You do not casually stroll or window shop a Power Center. You drive specifically to the Home Depot to buy a load of lumber, you pack it in your truck, and then you drive across the giant parking lot to Best Buy to get a new TV. They share the asphalt, but they absolutely do not rely on casual foot traffic walking between the stores.
And the absolute counter-trend to that asphalt sea is the Lifestyle Center. This is the model that really fascinates me.
It is the retail industry's attempt to artificially manufacture a nostalgic Main Street.
Right.
Open-air walkways, lovely tree-lined pedestrian streets, boutique indie coffee shops, fancy water fountains, nice wooden benches, and absolutely no roof.
Now, why remove the roof? Isn't that terrible for bad weather?
It is a calculated trade-off. Massive enclosed malls are incredibly expensive to heat in the winter, cool in the summer, and keep lit up. Lifestyle centers push all those heavy maintenance costs way down because the walkways are outside.
Oh, that makes sense.
And psychologically, they appeal heavily to upscale, affluent shoppers because it feels like a charming little village. It feels significantly less like a high-volume consumption factory and much more like a pleasant leisure activity. You go there to just hang out with friends, and oh, while I'm here, maybe I'll buy a $300 sweater.
It's sneaky. And what about the humble strip mall? Is it dead?
Not dead, but even that is heavily evolving. The old, ugly concrete strips with zero trees are dying out. Modern city zoning now explicitly requires heavy landscaping buffers, trees, and much stricter uniform signage rules. The city planner simply doesn't want an ugly, barren scar of parking directly along the main road anymore.
But the biggest retail trend the source mentioned, by far, is mixed-use development.
Yes, smart growth. This is putting high-density residential condos directly on top of ground-floor retail. It is the absolute darling of modern urban planning right now.
Why is it so popular?
Because it instantly creates a captive, built-in customer base for the commercial stores. The hundreds of people living upstairs in the tower naturally buy their morning coffee and groceries downstairs. And critically, it drastically reduces city car traffic because those specific residents don't actually need to drive their cars to get their daily essentials.
Okay, let's move to part 7. The workhorses of the real estate world. Industrial buildings.
Yes.
These buildings aren't usually pretty, but they really seem to be where all the smart institutional money is going lately.
Industrial real estate is entirely about pure utility.
Yeah.
It is the hidden engine room of our entire economy.
Right.
The source classifies them heavily by their adaptability. First, you have general-purpose buildings. These are essentially just giant, cavernous, empty shells. 4 blank walls and a high roof.
Which makes them a very safe investment. Right.
The safest. Because if your current tenant goes bankrupt and leaves, you can easily rent that empty box to almost anyone else. A logistics shipping company, a light furniture manufacturer, a self-storage facility. It is a completely blank canvas.
And what are the risky ones?
Single-purpose buildings. Think of a massive, highly complex oil refinery or a heavy steel smelting plant. The entire physical building is intricately designed around the specific machinery inside it. The concrete floors are heavily reinforced in very weird, specific spots. There are deep pits and heavy cranes built permanently into the structural steel.
So if the steel company goes under and closes the plant, who buys that building?
Almost nobody. You cannot easily put an Amazon warehouse inside a rusty steel plant. It's way too specific, so the building usually just becomes a massive teardown. That is a very high-risk investment.
Now, we talked about clear height earlier, but the design vocabulary of industrial buildings has some other very specific terms, like bay depth and clear span.
Right, and it is all about accommodating the forklift ballet.
The forklift ballet.
Yes. Clear span is simply the open distance between the vertical support columns. If you are a warehouse worker driving a heavy forklift at 15 miles an hour, columns are your absolute worst enemy.
They just get in the way.
They are massive collision hazards, and they waste valuable floor space. A modern, efficient warehouse demands a massive clear span, maybe 50 or 60 feet wide, so they can easily drive around and rack pallets efficiently without hitting steel poles.
And what about loading docks?
Absolutely crucial.
Yeah.
A warehouse is essentially just a giant box that semi-trucks physically plug into.
Right.
You need truck-level docks, which are usually elevated about 4 feet high, so the forklift can drive straight off the warehouse floor directly into the back of the trailer. And you need dock levelers, those heavy, adjustable metal plates that smoothly bridge the height gap between the building floor and the truck bed.
And if you don't have them?
If you buy an old warehouse that only has drive-in doors at flat ground level, you instantly cut off 90% of your potential corporate tenants. Because big 53-foot semi-trucks literally cannot unload their cargo there.
And usually we see these massive buildings clustered closely together in industrial parks.
Which is a very deliberate zoning strategy. Industrial operations naturally create a lot of noise, heavy ground vibration, weird odors, and constant heavy diesel truck traffic at 3 in the morning.
Yeah.
You definitely don't want that situated right next to a quiet residential kindergarten. So city planners aggressively group them all together and put strict buffer zones, like tall grass berms or sound fences, between the industrial park and the rest of the sleeping city.
Okay, we are definitely moving into the final stretch here. Part 8 covers some highly niche construction forms. First off, farms.
Right.
Now, I never really thought of a traditional barn as commercial construction, but the source firmly says it is.
It absolutely is. And you have to realize, a modern commercial barn isn't just a quaint little wooden shed with a happy cow standing in it.
Right.
It is a highly sophisticated multi-million-dollar industrial facility designed specifically for mass biological production. And there's some very serious math involved in placing them. The source details something called MDS, minimum distance separation.
Okay, what is MDS?
In the industry, we jokingly call it the smell math.
The smell math?
Yes. It is literally a complex mathematical formula used by the provincial government to calculate exactly how far a new livestock barn must be physically built from the nearest residential neighbor. And the distance is based strictly on the sheer number of animals and the specific type of manure management system they use.
So if a farmer wants to aggressively expand and add, say, 500 new pigs to the operation, they have to build the new barn significantly further away from the house next door.
Exactly. It completely protects the farmer from crippling nuisance lawsuits,
Yes.
and it protects the suburban neighbor from the overwhelming smell.
And farm structures are incredibly specialized, like silos.
Silos are true engineering marvels. A massive concrete grain silo might hold up to 20,000 tons of loose grain. The constant outward pressure pressing on those curved concrete walls is absolutely immense.
Oh, I bet.
And grain dust is highly combustible. If a sealed silo bursts or catches a spark, it's not just a fire, it's a massive lethal explosion.
Wow. Okay, and the other major niche discussed is multi-residential, apartment buildings. We see a lot of these 3- and 4-story walk-up apartments everywhere. Is that just a popular architectural style choice?
No, it is a strict, hard-nosed cost choice. It's called the walk-up limit. Generally speaking, the regional building code dictates that if a residential building goes over a certain height limit, which is usually 4 stories, the developer absolutely must install a commercial elevator.
And elevators are really expensive, I assume.
Incredibly expensive. Easily $100,000 just to install one, plus the very heavy monthly maintenance contracts forever.
Right.
So developers will cleverly design and build right up to the absolute bleeding edge of that limit, maybe 3.5 or 4 stories max, just to legally avoid that massive elevator cost. If you were looking at a brand new 4-story condo complex, the developer was absolutely dodging the elevator requirement, or at least dodging the requirement to put in a second expensive elevator.
It really always comes back to the cost, doesn't it?
Always.
Which naturally leads us right to part 9, future-proofing. Where exactly is this massive, heavy industry going? The source mentions something called BIM.
Building information modeling. Yes. For 100 years, we relied entirely on blueprints. Flat 2D paper drawings. You would have one set of drawings for the plumber's pipes, a different drawing for the framing walls, and you would just pray they didn't clash in the real world.
And I imagine they often did clash, like, oops, this water pipe needs to go directly through this solid steel beam.
Exactly. And fixing that clash on the job site costs thousands of dollars and delays the project for weeks. BIM completely changes that. It is a highly detailed 3D digital model. All the different trades, the plumbers, the electricians, the steel workers, they all work inside the exact same shared digital file. You can easily see the pipe hitting the steel beam on the computer screen months before you ever build it.
That's amazing. But the source specifically mentions 5D macro BIM.
Right.
Now, 5D, we obviously have 3D physical space. What on earth are the other two dimensions?
Time and cost. With 5D, you can fully simulate the actual day-by-day construction process digitally. You can literally see, okay, if we decide to move this lobby wall 3 feet to the left, the software instantly calculates that it will add exactly 3 days to the construction schedule and exactly $10,000 to the materials budget.
Wow.
You basically build the entire building virtually, you fail virtually, and you fix your mistakes virtually long before you ever pour a single expensive drop of real concrete.
That honestly seems like an absolute no-brainer for any massive commercial project.
It is the new standard.
And finally, the source dives into green energy and LE certification.
LE. Leadership in Energy and Environmental Design. It's basically a massive point system for green buildings. You get a few points for high energy efficiency, points for using locally recycled materials, points for installing bike racks, points for smart water conservation.
Right.
And if you score enough points on the checklist, your building gets formally certified as silver, gold, or platinum.
Now, be honest. Is this just an expensive PR plaque for the lobby? Just bragging rights? Or is there real, tangible financial value there?
10 years ago, it was mostly just bragging rights. Now, it is pure economics. First off, LE buildings genuinely have much lower monthly operating costs because they physically use significantly less energy and water.
Which saves money over time.
Right. But far more importantly, the major wealthy corporate tenants like Google, Amazon, or massive government agencies, they often have strict internal corporate mandates now that say they are legally only allowed to lease office space inside LE-certified buildings.
Oh, wow. So if a developer refuses to build green, they are actively cutting themselves off from the absolute highest-paying, most stable tenants in the market.
Exactly. It is rapidly becoming a mandatory market requirement for survival, not just a nice-to-have PR bonus.
So we have finally unpacked the skeleton. We've closely looked at the physical bones, the guts, the zoning laws, the terrifying hidden soil toxins, and the digital future of construction.
We've definitely covered a massive amount of ground today.
So it's synthesis time. What does all this technical knowledge really mean for the average person just walking down the street tomorrow?
I think it means realizing that a building is truly never just a building. It is a frozen physical compromise. It's a permanent snapshot of a very specific moment in time where human technology, what we physically can build, collided with law, what we are legally allowed to build, and economics, what we can actually afford to build.
Yeah.
And they all intersected right on that specific corner.
It really fundamentally changes how you look at the city around you. You look at that aging suburban strip mall, and you don't just see a boring discount store anymore. You actually see the setback distance from the road. You see the thermal mass of the masonry holding the afternoon heat. You see the flat, classy office space awkwardly stacked right above it.
Yeah.
You start to see the incredibly rigid logic sitting right behind all the visual chaos. And you realize that the shape of our world isn't accidental at all. It is heavily regulated and strictly calculated right down to the quarter inch. I love that. Now, here is my final provocative thought for you, the listener, to take away.
Let's hear it.
We talked heavily about adaptability earlier. We talked about how general-purpose empty warehouses are super easy to reuse for new businesses, but those highly specific single-purpose factories are incredibly risky when the economy shifts.
Yes, very risky.
Look around your own city today. Really look at it. Look at the massive enclosed suburban shopping malls that are visibly struggling right now. Look at the towering downtown office buildings that are sitting half empty because everyone shifted to remote work.
It's a real problem.
Are we currently sitting on a massive trillion-dollar pile of obsolete single-purpose skeletons?
That is the absolute billion-dollar question right now in the industry. Can an aging office tower practically become a vibrant apartment building? Can a dead, enclosed mall become a modern university campus?
Or will they just slowly become the hollowed-out Rust Belt factories of the 21st century?
It's a scary thought. Because the absolute most sustainable building you can own is the one that can easily become something else tomorrow. If we built our cities too rigid, we might have accidentally built a future ghost town.
Definitely something to mull over the next time you drive past a massive steel construction site. Thank you for taking this deep dive with us today.
It was a pleasure, as always.
See you next time.